Hi everyone, I'm Shin. Yeah, I'm a technical contributor at Origo. Today I'm going to give everyone an introduction about Origo. So maybe before I get started, I want to know a little bit about people's background. For example, how many of you heard of smart contracts? And how many of you have some knowledge or idea of what a hash function is? And how many of you heard of zero knowledge proof? Okay, it's pretty good. Okay, so yeah, I will get started. So if in the process, if you have any questions, feel free to ask. So maybe let's first get some background. So Bitcoin enabled people to send money through a peer-to-peer network without any trusted third parties. And Ethereum has taken a step advanced of that. It allows people to build smart contracts. Basically, developers can write programs and apps published as smart contracts. It runs on the blockchain using a peer-to-peer network without relying on any trusted third parties. It opens a lot of more applications. Besides simply send money to peers, you can also, for example, you can issue your own ERC20 token on Ethereum. You can do in your ICO. You can do, for example, a crowdfunding campaign like Kickstarter. And for example, you can play crypto kitties. You can buy kitties, trade them, and for example, you can also do votings. Yeah, it enables a lot of the applications. But we think one problem is that in current smart contracts like Ethereum, there is no privacy. Basically, everything is public. The transaction is public. If you send some Ether to anyone, the sender, who is the sender, who is the receiver, what amount you are sending is public. And the contract code is also public. And for example, if you call a contract, the input is public, the execution details is public, the result is public, and if you have any Ether that's interacting with the contract, how much you send, how much you receive is also public. The reason is that the only way to verify that, for example, a contract is executed correctly is that every node in the network will rerun the contract using the input, and they will compare does the output match. So in this way, all the details needs to be shared for all the nodes in the network. So we think this definitely brings some problems because yes, some of the contract has some sensitive information and people do want to keep it private. And so there is cryptos like Zcash or Monero, they solve part of the problem. They support private transaction, which means you can, when you send some money to someone, they can hide, for example, they can hide the transaction amount, and Zcash can hide the transaction amount, and they can also hide the sender and the receiver address. So in this way, the transaction is private. But one problem is that those technologies, they doesn't support smart contracts. So the smart contracts is still public. And this is a comparison between the different privacy scopes for confidential transaction and also for privacy preserving smart contracts. And we can see that for private transaction, the most confidential transaction, they most focus on hiding sender address, receiver address, and the transaction amount. But they cannot hide anything related with contract, such as the input to contract, the execution results, and also the tokens related with contract. And we believe that smart contract does need privacy. Let's take some examples. For example, for an insurance contract, the input to the insurance might be very sensitive. For example, it might include your personal data, like your date of birth or which disease you want to buy insurance. This information is very private. You definitely don't want everyone to see it. And also how much you are paying for the insurance contract and how much you can get paid if something happens. This information might also be sensitive. You want to keep it private. And also, let's take some auction and gambling contract as an example. For example, if two people are playing a simple game like rock, paper, and scissors, if the input is not private, as long as one party make a choice and another party can just counter his choice by doing some front-running attack. And also, for example, for voting contracts, since sometimes people don't want their vote to be public. For example, if you vote for someone which is not popular among all the people, maybe you want to hide your vote. So all these things cannot be simply run on current Ethereum because Ethereum doesn't provide the privacy protection that people want. And maybe let's look at simple examples, how to play rock, paper, and scissors on Ethereum. And initially you might think, oh, this is easy, I just write a contract and people just submit their choice, is rock, paper, or scissors. But then you soon realize that there is some problem. As I said, you can't just directly post your choice to the contract, because as long as you post your choice, your opponent will see your choice, and he can simply counter your choice. You post a rock, and he can just post a paper, and he will win. So is there a solution to solve this on Ethereum? Actually, yes, there is some patterns to solve this. There is a pattern called hash and reveal pattern. So actually it has three phases. In the first phase, instead of directly submit your choice, rock, paper, or scissors to the contract, you actually submit a hash of your choice plus some random string to the contract. The reason that to submit the hash is you are not submitting your choice, so your component cannot see what your choice is. But the advantage is that since you already submitted a hash function, you cannot alternate your choice later. For example, if you submit your choice of rock and some random string into the contract, later you cannot say, okay, my choice is actually paper, because you need to find another random string such that the hash of this two equals your previous hash. This is pretty hard or almost computational impossible. And so after the commit phase, when both parties have submitted their commits, and these parties can reveal what their choice is by submitting their choice and the random string to the contract. And the contract can just compute a hash function to verify does this input match the hash that they submitted in the commit phase. If it's matched, then this is a valid choice. And yeah, when both parties reveal their choice, and then we can execute the contract, compare who is the winner, and distribute the funds. So this pattern, yeah, it's so the privacy is temporarily preserved using this pattern. Basically, you preserve the privacy before the open phases happens. However, this approach might be good enough for this game because after the game ends, maybe no one cares about what's the privacy of your choice. But for some of the applications that I just mentioned, this may not be enough. For example, for an insurance contract, maybe you want to keep your personal data private forever. So this pattern is not enough. So yeah, this pattern is not enough. And so then I'm going to start to give some introduction about what is our overall solution. So basically, our solution is kind of like similar to the previous solution, but we have in the commit phase, people also submit a commitment of their input, a hash of their input. But in the second phase, instead of directly opening this input and execute the contract on blockchain, we will execute the contract off-chain to ensure that privacy is preserved. Because the reason is that because if we still execute the contract on blockchain, then everything will still be public. There is no privacy. And so after the contract is executed off-chain, and we will use zero-knowledge proofs to verify that the contract is correctly computed. So this is some high-level idea of how we are solving this privacy problem. And I think now maybe let's give a little bit introduction about zero-knowledge proof. I guess maybe not everyone have heard of it. So basically, this is some techniques that a party can prove to another party that he knows X, but without revealing any information about X. For example, a party can prove to me that he knows answer to a particular Sudoku, but without telling me what the actual answer is. And recently there are also some techniques called ZK snarks, which is short for zero knowledge succinct non-interactive argument of knowledge. And basically, the one advantage of that is it doesn't require any interactions between prover and verifier. Maybe let me give you a quick, very intuitive example of a simple zero knowledge proof. Let's see, this is not a very rigorous example, but it can give you some high-level idea of how ZKP works. For example, let's say there are two boards with identical look but different colors, and let's say a red one and a green one, and a color-blind person can't distinguish the color. So how can you prove to him that the two boards indeed have different colors, even without letting him know which color it is? And there is actually some solutions. For example, we can let the colorblind people hide both boards behind his back, and first he will show me one board, and then he takes that board back, and he randomly shows me another board, and I need to answer, the two boards he showed, are they the same? If the two boards indeed have different colors, then it's very easy for me to answer, and because I can tell just by if the two boards are of different color. So, but if the two boards are of the same color and I can't tell the difference, and every time I can just give him a random guess, I only have 50% of chance of getting the correct answer. So we can repeat these steps for enough times, and so the probability that we can get a correct answer with so if the two boards indeed have the same color and I can't distinguish, the probability that I can get correct every time is really low. So after we repeat for enough times, I think the people of colorblind will be convinced that, okay, these two boards are indeed have different colors. So this is a simple example, but in this example, one drawback is it requires a lot of interaction between prover and verifier. This is not very practical on blockchain because we can't do that many rounds of interactions. Yes, but recently there are some techniques like ZK snarks. Basically, it doesn't require any interaction between prover and verifier, so it can be used in blockchain. And it's used in Zcash to prove the private transaction is valid. For example, when one makes a private transaction, he can use zero knowledge proof to prove that, okay, I know the secret key of this address, and the amount of the output sum equals to the amount of the input, so this is a valid transaction, but it will not reveal any information about what is the sender's address, what is the receiver's address, and what is the amount in the transaction. Yeah, so this is basic ideas. And this is some overview of our protocol. So basically, as you can see, it still has 3 steps. I will discuss a little bit. I will discuss each step in details. And so basically, there are 3 roles in the protocol. The first role is contract participants. They want to keep their input and output to the contract private. And there is also another role called executor. It will execute the contract off-chain, and after the execution is done, he will submit the result and the zero-knowledge proof to the blockchain. And yeah, let's get into some details of each phase. And so the first phase is commit, and it's actually quite similar to what the commit is doing in that rock paper and scissors game. Basically, each participant will submit a hash of their input and their private coin to the smart contract. The idea is to, after the commit is submitted, the parties cannot change their input. But since we are only submit a hash, no information about the input is revealed. And the contract will verify that since the participants also send some money to the contract, send some private coin, and the contract will verify, okay, this coin is indeed valid, and it will freeze the coin. And in the second phase, basically we want to compute the contract. So each party now needs to open, instead of open their input directly to the blockchain, if they open their input directly to blockchain, then everyone else will see it. So instead, they will open their input to the executor, and the executor will run this private contract off-chain such that the input will not be leaked. And after the computation is done, the executor will generate a zero knowledge proof that okay, the result is correctly computed using the encrypted input. And the last phase is settle. So basically, after executor submitted the result and proof to the blockchain, on blockchain, the smart contract will verify that the result is indeed correct, and it will distribute the tokens back to the party based on the result. And this is some comparison of what Origo's private smart contract can achieve versus the traditional smart contract like Ethereum. In the example, as we can see, by using some of the hash reveal pattern, in Ethereum, it can temporarily protect the privacy of the input, but it's only temporary. From the moment that you open your commitments, those information will be available to everyone. And also, Origo can protect the privacy of contract execution. So how in the contract code, for example, which flow you are doing and some intermediate result of the computation are also private. And also the output of the contract execution is also private. And besides any transaction, either you are directly send a transaction to a people or you send a transaction to the contract, the amount of the transactions will also be private in Origo. Yeah, we think that by enabling the privacy preserving for smart contracts, we will open a lot of new applications for blockchain. And as a developer at Origo platform, they don't need to have deep knowledges about zero knowledge proof and those stuff. Basically, they will write smart contracts, still similar to how they write smart contracts on Ethereum. They will add some annotation like I want this part to be private, and our compiler will automatically convert it to zero knowledge proof circuits, and also we will generate those protocols automatically. So those contracts will be executed using the protocol that I just described. So basically, contract developers doesn't need to implement these protocols by themselves. And yeah, and also let me introduce a little bit about our infrastructure. So we are building our own blockchain. The reason is that although theoretically some of our functions can be implemented on Ethereum, but there are some scalability problems because computing zero knowledge proofs takes some computation power, and the current Ethereum gas limit does not support that, and also Ethereum does not support private transaction. So There are several reasons that we want to build our own blockchain. The first reason is to improve scalability. We will, for example, we will do some computation sharding to improve the computation power on our blockchain, such that we will have enough computation power to verify zero-knowledge proofs. And we will also develop better support for zero-knowledge proofs. And the third reason is that our own blockchain will enable private transaction, so people can do private confidential transaction on our blockchain. And so what kind of applications can be benefits from Origo? We think that there's a lot of real-world contracts that really needs privacy. For example, for salaries, if there's a payroll contract, no one wants his salary to be public to everyone. And for insurance, as I said, the input data and what kind of insurance you are buying, it reveals what kind of risks you care about. You definitely want to keep it private. And also for supply chains, for example, sometimes what price you paid to get the goods, maybe you want to keep it private. And there are also a lot of other examples. For example, in an auction, people want to keep their input, keep their bids private before the auction happens. And also for election, voting, some health applications. Yeah, a lot of the applications will be benefits from Origo. And this is our roadmap. So basically at the end of the year, we will launch our testnet. That supports confidential transaction and also supports smart contracts. And around June of next year, we will release our mainnet. And at the end of the next year, our mainnet will enable some built-in privacy-preserving smart contracts. And on June of 2020, our full net will be available. Basically, developers can create their own privacy-preserving smart contracts, and yeah, they can verify it using our net. Yeah, this is the summary. I think one thing I want to emphasize is, yeah, we do believe that privacy is a very important part for blockchain, because now by default, a lot of stuff are public by default for blockchain. It really limits a lot of the applications. And our hope is that by providing a privacy-preserving decentralized application platform, we can allow more privacy-sensitive applications running on our platform. And if you want to know more details, you can go to origonetwork to read our white paper. And yeah, I think I ended a little bit early. So does anyone has any questions?
Yeah, I have a few. Regarding the test, is there already any
so yeah, we have our GitHub is still private, but we already have some very simple proof of concept code, like for example, proof of concept of using zero-knowledge proof to verify some contract execution.
Yeah, so you guys are already working.
Yeah, we're already working on it.
What I'm also wondering about that's the privacy aspect. A lot of problems today seem to be don't get listed on machines if you don't very privacy. Do you see where the problem is? Do you see where there is stuff like that? Like when you list on machines, privacy don't change.
So your question is, for example, if some tokens get listed in a private way, so does it bring?
Applications are like also kicking out a lot of regulations.
I see. Yeah. I think I think it's definitely there's some sensitive part about privacy, because people might be concerned that if everything is public, then how does regulators regulate it? Yeah, but I think one important thing is at least we should provide a technical possibility for them to implement privacy preserving. At least we should have the technology ready. And it's more like the developer's choice of does he wants to use public token or private token. But I think at least for some of the applications, maybe there is some use case where there is some need for privacy, then hopefully our solution can be useful to them.
Okay, so you mentioned that you're going to have a compiler that can take normal developer code and compile it into something that's Snox compatible.
Yeah.
Can you provide more details on that?
Yeah, I think this is actually a very challenging part because, I think the way that we are thinking is that maybe initially we will start with some more limited functions. For example, we will support. I think it's very hard to, for example, directly compile existing Solidity code into the circuit. So I think what we are going to start is when we want to start with compiling some code with more limited functions, and we will gradually expand to support more functions. And I think one reason is also, I think, a lot of times that applications really cares about privacy. Maybe a lot of them are financial related, and the most important computational operations are arithmetic computations, and we will start those first, and we will gradually add more support. Yeah.
You very correctly said that you can do certain things on the Ethereum blockchain, but currently will probably run out of gas.
Yeah.
Did you check if we compiled arithmetics on LP and how maybe you can do those functions?
With what?
So I think it's either already on internet or it's on testnet, precompiled arithmetics on the LP and on.
Oh yeah. We have verified that. For example, Ethereum has some pre-compiled contract verify zero-knowledge proof, and even running some simple computations like, for example, proof 1 + 2 = 3. I think it consumes about half of the gas limit in a block, and so that's why if you just do it in this way, you can't support really any complex computations.
Yeah, I guess it was made before precompiled arithmetics.
Oh, I see.
And I think now it's still kind of a lot of gas, but at least makes private transactions feasible.
Oh, I see. Yeah, we will check that.
Not more complex.
Yeah.
Hi.
Hi.
Thanks a lot for your presentation. How do you disincentivize executors from selling the data you're trying to keep private?
Yeah, this is a very good question. I didn't talk too much detail about that in the presentation. Yeah, but I think there are several solutions to that. I think the first solution is that a lot of contracts, actually, participants want to protect their privacy, not against each other, but mostly against the outside public. So in these situations, actually, we can choose one of them to be the executor. In this way, they will not reveal the information. And another way to do it is that our protocol guarantees that even in the worst case that the executor reveals some of the information, it will not affect the correctness or fairness of the contract, because the commit already happens. It will still execute. It only kind of like affects the privacy after the execution is done. And so to solve that problem, there are, to even better protect the privacy after the computation, there are several solutions. For example, one solution is we can run the executor on a trusted hardware like Intel's SGX. But I think one thing we don't fully trust SGX, but I think maybe at least it's better than having no protections at all. And one thing I want to emphasize is we are not trusting it for the correctness of the execution. We only trust it for keeping the privacy. And I think another approach is in the most extreme case, if two parties really cares about their privacy, they can also do the computation using multi-party computation. So in that way, the information will not be leaked. But that will have more computation overhead. So in that sense, privacy is a trade-off. So it depends on how much do they care about the privacy and what kind of price they want to pay. So we will provide multiple solutions, but in the end, it's the participant's choice.
Thanks for the presentation. I believe Ethereum is working with Zcash to add a privacy layer to Ethereum, and I think there is already a private blockchain implementation in JP Morgan to do that. How your approach would differ from what Zcash can do on top of Ethereum?
Yeah, I think, I know that, Zcash is collaborating with Ethereum, and Ethereum is also incorporating zero-knowledge proof. I think the focus, the focus is different, and I think, for example, our focus is to using this to not only support confidential transaction, but also support the privacy of smart contracts. And I think another reason is that actually things are kind of like going in a slower pace in Ethereum, because I think for some of the things that you mentioned, they have been planned for a long time, and it really takes a lot of time for them to happen. For us, we can't wait everything is ready on Ethereum, and we can't just wait until Ethereum is ready. So that's the reason that we want to build our own chain. And I think another reason is also that since Ethereum is already a very large community, and people have different interests. For example, some people have interest in privacy, but maybe other people are not that interested. As you mentioned, some people might even be afraid that, enabling private transaction on Ethereum might make regulators doesn't like it. So there are different opinions in Ethereum. So things are definitely moving slower in Ethereum. So our hope is that by building our own chain, we can move things much faster and deliver these things faster.
Do you have a rough estimate of transactions per second, or what the scalability of the platform looks like? And then second question, any thoughts around ZK Starks, the newer, version of Starks?
I think for the first part, since I didn't talk too much details about our plans for scalability. I can briefly. So basically, we will have some improved consensus algorithm, and we will also do computation sharding. I think our hope is that maybe we will support around thousands of transactions per second. And I think we are not targeting something, for example, like millions of transactions, and because we think that we either need to sacrifice some decentralization or we need to sacrifice security. What we want is to achieve a reasonable transaction per second, but also keep the decentralization and the privacy. And another question is regarding this Stark. ZK Starks. This is a good question. I didn't talk too much details about the difference between them. As you might know, I think one drawback of ZK Starks is it requires trusted setup. And for confidential transaction, this might be fine because you only need to do setup once. But for contracts, if you want to do trusted setup for every contract, it might not be that feasible. And I think the good part about ZK Stark is it doesn't require trusted setup, and its proof size and verification time is still reasonable, can be done on blockchain. But I think previously the biggest drawback of ZK Start is it requires a lot of memory to build the proof. So it's not that practical for some regular executors to boot the proof using ZK use their memory usage. Yeah, I think it's definitely we are considering ZK Stack as a potential to provide ZKP proofs to for smart contracts. Yeah, but currently it's not that matured yet. But yeah, we will keep an eye on it and find the best techniques that fit our needs.
Which jurisdiction is the issuing entity incorporated in?
Maybe Baron? Is Baron here? Yeah, maybe Baron can answer this question since I'm more focusing on the technology side.
It'll just be time for Michael and then come back to this issue. We'll come back to this question at any data.
Okay, yeah, we'll answer it later.
More questions?
You mean our consensus algorithm? So basically, we will have a hybrid consensus algorithm. Basically, we will use either proof of work or proof of stake to identify some identity blocks. Basically, it's the candidates of validators, and on top of that, we will randomly select some validators and run PBFT to reach the consensus. The advantage is that we can keep it decentralized, but we can also achieving the efficiency of PBFT. So I think the details of how we are selecting identity block, either using POW or POS, are not, we haven't fully decided, but we should be very compatible to both approaches.
So it sounds like there's a testnet out. If you had to give us a rough roadmap of what to expect for the rest of this year, how would you see the mainnet launch? And okay, that works. And in terms of like exchanges that you want to be on, how should we be thinking of how many by certain points, or how do we hold you guys accountable to what you're?
You mean which exchange will be listed?
Not which exchanges, but kind of like, do you have a target in terms of how many exchanges by when, etc.?
Okay, I see. Yeah, I think maybe Barry can answer these questions at the end of the panel, since I'm mostly focusing on the technology side. Yeah, is there any questions? Okay, sounds good. Thanks everyone for coming. And if you have any questions, feel free to talk to me or talk to other folks. Thank you.